Hello students, this is the second video where I want to show you what could be the danger of using relational operators to compare floating point numbers. And you may get a little shocked when you see that, but it's important that you understand the difference. Okay, so we have this little program here. Over here I have average of 3 integers. So int average, int type. So I say 16 plus 16 plus 16 divided by 3. So really, theoretically speaking, it should store 16. But we can check that. The way we check that, we say if an int average equals 16, then program should execute this code here. Otherwise, it should execute this code here that it's not equal to 16, and that would tell us whether integer division is accurate or not. Okay, now I'm going to comment out this code because I'm going to comment them in one by one. Okay, so we build and run, and our output window is here, and it's kind of small, but I'm gonna copy and paste that over here. Actually, can I increase the font here? I guess not, so I'm gonna copy the results here, and it's this. So it shows here the 16 plus 16 plus 16 divided by 3 is indeed equal to 16. So this code was executed, else block was not executed. Okay, all right, fine. This time I'm gonna comment this one out. Don't need to see that. And let's try to do the same thing with the double average, but this time I don't take 16, but I take 1.6. Okay. And let's see, I'm going to comment out this one too. So here I did the same thing, 1.6 plus 1.6 plus 1.6 divided by 3.0, and theoretically speaking, if I'm adding 1.6 3 times, dividing by 3.0, so it should really store 1.6, and we'll find out whether it does or not. So if it is indeed exact value 1.6, then I should be executing this block here, which will say the 1.6 plus 1.6 plus 1.6 divided by 3.0 is indeed 1.6. But if for some reason this doesn't score 1.6, then this else block will execute, which says that 1.6 plus 1.6 plus 1.6 divided by 3.0 is actually not 1.6. Well, let's find out whether the if block executes or the else block executes. Okay, so let's run it. Okay, yes. And this time I get this result where I'm gonna copy and paste at the bottom. It's kind of small to see. And surprisingly enough, this time I get this result, that over here, that 1.6 plus 1.6 plus 1.6 divided by 3.0 is not 1.6. Wow, that's shocking, isn't it? So really, it didn't execute this block here, rather it executed this block over here. So this looks like this is a certainty that if you add 1.6 3 times, divide by 3.0, you're not going to get 1.6. Okay, so that's the danger of using relational operator, in this case equal for the floating point numbers. Understand that double is a double precision of float. You might get even more error if I had used a float here. Certainly this won't be true for the float. But let's see if we can get lucky by increasing precision. Uh, twice the precision of double is long double. So let me see if I can do a little better with the long double. Well, in order to use the long double, we need to just copy and paste that code here. I'm going to comment out this code because I don't want to see any results from this code up to here. And let's say long double. Well, if we do that, we have to add a suffix L to each one of these. Otherwise, it will no longer long double. And do this, oops, not there, sorry, over here. Let me call it double average 2 so that we don't confuse with the other one actually. And let's say when we use long double, and same thing I'm going to add at the bottom here. Okay, let's try this time, see what we get. Save on. And this time, surprisingly enough, one more time, we actually get what we are expecting. We get this result over here, that 1.6 plus 1.6 plus 1.6 divided by 3.0 is 1.6 when we use long double. So when we improve the precision, we got what we were expecting. So it looks like double didn't have enough precision for us to give the correct result. But when we use long double, which is twice the precision, twice the number of bytes of double, then we got lucky and we got it. Okay. Since normally we use double type anyway, it will still seem like that it's dangerous to use the relational operator for the floating point type. Okay. Now let's say we do use double type and we still want to use the comparison. How can we do it? Is there a technique we can use? Well, technique is using comparing the floating point number for small differences. So what we can do is, we had the double average here, which I have to code back in now, otherwise I would not get what I want. So let's just add our comment here. So this time I have the normal double average, 1.6 plus 1.6 plus 1.6 divided by 3.0. So although I'm expecting it to be 1.6, but it's not, as I'm seeing over here from this result, I can kind of test that, okay, is it really within some small value? Okay, is it within some small value? So really, basically speaking, double average over here could be actually greater than 1.6, slightly greater, or slightly smaller. That's why we were getting this output. So let's see if it falls within some very small tolerance. So the way we do that is we subtract from double average 1.6 and then take the absolute value of that, because if this is larger, then we'll get a positive value. If it is smaller, we'll get a negative value. We don't want to deal with the negative number. So fabs is the absolute value of a floating point number. So this function, when we pass it, this value is going to return a positive number, positive small number, because the difference between these two is pretty small. And then we say that if this difference is smaller than this number here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 1 into 10 power minus 13, which is actually a very small number. So we are saying that if difference between these two, absolute difference between these two is smaller than a 10 power minus 13 number, that means for all practical purposes we are going to consider them to be same number. Okay, so that's like trying to see if they are within some tolerance, and if they are within that tolerance, we'll, for all practical purposes, we're going to assume that they are the same. So let's see what results we get this time. Okay. Save. And this time we do get the result that we were expecting. And it says the 1 point over here, the 1.6 plus 1.6 plus 1.6 divided by 3.0 is almost 1.6, which means it is executing this statement here and skipping the else block. Okay, so this really gives us the model for testing the two floating point number, in this case for equality, of course, but you can do less than or greater than equal or less than equal also using the same thing, that if they are within each other within certain tolerance, then you can consider them equal. If one is greater than the other within certain tolerance, then of course we can consider them to be different. Okay, so this is one example of showing the danger of using relational operators for floating point numbers. When we do loops, we'll show you another example of that if you run a loop based on for loop based on floating point number, you're not going to get correct number of cycles, loop cycles that you're expecting. All right, ebook has another example of using a floating point float data, and you'll see there also you will find out that it doesn't, comparison operator or relational operator on floating point numbers don't work very well. All right, so we try to avoid comparing floating point numbers as much as we can, but if we do have to compare them, then we compare them for small differences, small tolerances. If they are same within certain small tolerance, we'll for all practical purpose consider them to be same. All right, that's it for this video, and stay warm from the weather, and thank you. Bye.